thickness of the ice.
The submarine Nautilus on the first transpolar voyage from Pacific to Atlantic Oceans. A continuous record of water depth and ice thickness is obtained by the Nautilus safely on its silent and visible cruise below polar ice, which is on an average 12 feet thick, with some ridges extending down 50 feet and even farther.
This was the Cold War, and the Americans were convinced that the Russians had submarines that could break through the ice and potentially launch a surprise nuclear attack. But crucially, it depended on how thick the ice was.
So for over 30 years, the military kept detailed secret records of the ice thickness. Then, when the Cold War ended, the American Navy invited civilian scientists to join their missions. Once more, they headed under the pole, measuring the thickness of the ice as they went.
What they discovered was that the ice was 40% thinner than it had been when the measurements were first taken. It had gone from an average thickness of 3.3 metres, which is the height of this face of an iceberg, up to about just over my head, down to a height of about 1.9 metres. In other words, in 40 years, it had virtually halved.
It was an astonishing change in such a short space of time. But it wasn't just that the sea ice was getting thinner and melting earlier. There was also a third change. There was a lot less of it. Over the last 30 years, satellites measuring the extent of summer sea ice have recorded its decline. By 2005, the sea ice had shrunk by almost 20%. And by 2007, it had a new record low when an area about 10 times the size of Britain disappeared. Scientists have put all these changes together, the earlier melt, thinner ice, and a reduction in the extent of sea ice, and some now fear that within a little over a decade, sea ice could vanish in summer altogether.
Rapid climate change is already happening here. The reality is that we may be on the verge of crossing a threshold into a world where the Arctic is ice-free every summer.
And if that happens, could it lead to a further acceleration in warming? Even help cause a sudden leap in temperatures like the one at the end of the Younger Dryas? The truth is, no one knows. And there's the rub. The models say global warming will be slow and steady, and that's bad enough. But the lesson from history is that when change comes, it can be very sudden.